Hi, I'm Mary Susan from Jessamine County Adult Education Skills U, and in this video I'm looking at a fourth kind of algebra word problem. I'm working through about 6 different kinds of algebra word problems that you can see on the GED test, and this section I've titled Age or Weight in Future or Past. But when I went looking for questions about weight, I really couldn't find any. So I think they might have taken their focus off weight gain and weight loss because it's kind of a controversial issue. And I think maybe they've focused all of the problems that they're putting on the test now on just age in the future or past. But if you did come across a weight question, they'd be worked in the same pattern. So we're going to look at some age questions in the future and past. And I want to say that if you've seen a question like this before and you've been totally lost, that's just fine, because if you think back to consecutive number questions, if you didn't know the pattern of x, x plus 1, and x plus 2, and so on, there wouldn't be any way for you to work that question. And this is exactly the same thing. There's a pattern for how you lay this question out, and if you don't know it, it's really not solvable for those of us who can't think like this just in our brains. So don't feel bad if when I even read this question you think, oh gosh, it's one of those and I'll never be able to do it, because I'm going to show you how to lay it out so that you will be able to. So first we're going to start with Carrie is 3 times as old as David. In 5 years, Carrie will be only twice as old as David. How old will Carrie be in 5 years? So we're just going to take this a little bit at a time like we have before, and we see that we've got Carrie and David. So we're going to make 2 columns on your notebook paper, one for Carrie and one for David. And the first couple of words here tells us that Carrie is 3 times as old as David. So we're going to put 3x for Carrie, which means David will just be x. Because you're always going to have one column will have x and the other column will have x plus additional information. So in 5 years, which means we're going to show 5 years from now added to both Carrie and David, Carrie will only be twice as old as David. And I'm going to do something a little different with this twice. I'm not just going to put down the number 2. I'm actually going to write out the word, and it's always going to go with the person who has the single x. So even though it says Carrie will be, don't worry about where you think the twice is in the sentence, because it's always going to go with the single on the column with the single x. And I've used the word twice instead of the number because as I write out this equation, I want to notice that that's something a little bit different. So if I write out Carrie's side of the equation, she's 3x plus 5. And that's equal to David, who is twice, and this is where my twice comes in, it's 2 times the column x plus 5. I don't know if that will help you, but it really helps me not to come back later and see a 2 there and think, oh, do I add this 2 or subtract this 2? When I write out the word, it always reminds me that, oh, I'm going to use that 2 and multiply with parentheses. So now that we have the equation written out, we're going to distribute the 2 into the parentheses part. So I'm just going to retype the beginning of this problem so that I'll have it on the next line to use. And then I'm going to multiply 2 times x, looks like that, and 2 times 5 looks like this. I want to get all my letters on one side of the equal sign and all my numbers without letters on the other side of the equal sign. So I want to get the 2x over to this side, and since it's a positive here, I'm going to do a negative on this side, so I'm going to subtract 2x from both sides. And then since I have a positive 5 on this side, I want to put it as a negative or subtract 5 on this side, and then I'll be able to subtract so that I have all my x's on one side, all my numbers without letters on the other side. So 3 minus 2 will be x, and 10 minus 5 will be 5. So 5 is the amount of David's age. But the question is, how old will Carrie be in 5 years? So Carrie will be the 3x plus 5. So I've written that 3x plus the 5 years will be Carrie's age. If I put a 5 in the spot for x, so substitute 5 for x, then 3 times 5 will be 15, plus 5 will be 20. So Carrie will be 20 in 5 years. I know that's a lot of work, but that's exactly how it's going to be. It's going to be set up the problem, work the problem, and then if you don't get the amount for x, you're going to have to do another step in order to find the amount for x. So let's try another problem. This one says Jerry is 12 years older than Stan. So again, let's start out with a column for Jerry and a column for Stan. And Jerry is 12 years older. So x plus 12 would be 12 years older than x. So Stan is going to be x and Jerry is going to be 12 years older. 5 years ago, so now I'm going to do minus 5 on both for 5 years ago. The sum of their ages were 28. So the sum is 28. So this problem is different from the last one in that the last one we had the two people, their ages were equal to each other, and we had that extra word to write in. But in this problem, we have the two people are added together for a sum of 28. So all we need to do is write down Jerry's side of the equation and add that to Stan's side and equal to 28. So now let's combine like terms. If we have x and x, that would be 2x. And if we have 12 minus 5 minus 5, that would leave 2. And that's still equal to 28. So 12 minus 5 minus 5 left 2. Now let's do the inverse operations to solve for x. So instead of add 2, let's subtract 2. Which will leave 26. And then we want to separate x from 2 here by dividing. And if we divide by 2, x will equal 13. So is that what we needed to know? Stan is 13? Well, they want to know how old they both are. So Stan is 13 and Jerry is x plus 12. So the reason I'm not using the minus 5 is because it says how old are they now. So Jerry right now is Stan plus 12. So if I substitute 13 for x, then 13 plus 12 will be 25. So Jerry is 25 and Stan is 13. So here's a problem for you to try, and even though you might think it's too soon, I've given you some clues at the bottom so that you can use the amounts in blue to write out 2 columns that represent the words in the problem. And then you can come back and we'll put those in the problem, or you can keep going and use the items in black to create and solve for x. So if we started out with Bart and James, we had a column for Bart and a column for James. If you put J here and B here, don't worry about it, it's going to come out exactly the same. So Bart is twice as old as James. So Bart is 2x and James is x. So now if you say, well, why didn't you write twice at the bottom somewhere? We only do that when that's at the end of the problem. When the problem starts out, you write that on the first line right under their names, and it's written out to establish which person is X and which person is X plus more information. 10 years ago, so we're going to have to subtract 10 years from both Bart and James. The sum of their ages was 46. So now that we have this part worked out, if you want to pause the video and attempt to solve it from here, or even just write out the equation on your own, that would be great. So when you wrote out the equation, you had 2x minus 10 for Bart, and you needed to add that with James, which was x minus 10. And together they equal 46. So if we combine like terms, we have 2x plus x is 3x, and negative 10 minus 10 is negative 20, and that's equal to 46. So now let's start doing the inverse operation. Instead of subtracting 20, if we add 20 to both sides, that will equal 66. And to separate the 3 from x, we're going to divide by 3 so that x will equal 22. And that's how old James is. How old is James? That's exactly what they wanted to know. So since that one didn't have the twice at the end, I've added another problem here for you to practice. And I've made it a little bit harder because now everything is in black. And you'll need to decide which things go to lay out the equation and which things to solve the equation. So pause the video now and see if you can do any of those pieces. So to lay out the equation, we had Bob and Ellen. And we see that Bob is 2 years away. So he's minus 2 from being twice as old. And Ellen will just get the simple x. Because one person is going to get just x, the other person's going to get x plus additional information. The sum of twice Bob's age and 3 times Ellen's age is equal to 66. How old is Ellen? So if you want to pause here and see if you can use the remaining amounts to work to do the solution for the problem, do that now. So our equation for Bob's side was 2x minus 2, and that was going to need to be done twice. And then we were going to add to that Ellen's side of the equation, which was 3 times x. She's going to have x 3 times. So if we distribute that 2 times 2 will be 4x, and 2 times negative 2 will be negative 4, or just minus in between the two numbers. And then on this side, if we have 3 times x, 3x is going to equal 66. And I could have had this equal also at the top, but just forgot to put it up there. So now I'm going to try to combine like terms, and I have a 4x plus 3x will be 7x. And instead of subtract 4, if I add 4 on both sides, 66 plus 4 will be 70. And then if I separate these multiplied items by dividing, I'll divide by 7, and that will be 10. So Ellen is 10. And that's what it asks for. How old is Ellen? So I'm leaving you with some practice problems that were from video 3 and this video numbered 4 together. And I'll give you a chance to work these, and then you can come back to a follow-up video and see what the answers are and how we work them. So thanks for joining me for this video on age, future, past, and word problems.